Good to go?
Yes.
Okay.
Yeah.
Hello, everyone. My name is Richard Flores.
I'm Natasha Menon.
We're from Marymount University, located 6 miles from Washington, D.C. in Arlington, Virginia, and we are recognized as a center of academic excellence in cyber defense. The agenda today will go over introduction to the team, our research project, including user stories, our problem statement, use case, the objectives, phases, and our results, and then finally using and maintaining our cloud deployment, and then ending with a conclusion and Q&A session. Our project team was led by Dr. Murphy and Dr. Alex off to the side here, both faculty at our school. Natasha Menon is a computer science major, graduated in the spring, now works as a computer scientist for the Department of the Navy. I'm a cybersecurity major, and I currently intern at ECS for CISA, doing security engineering. So to begin, what is a red team? Red team is basically good guys pretending to be bad guys. They emulate adversary actions so that the blue team can both train and identify any gaps. They run through scenarios. It's a little bit more in-depth than like a pen test in that they try and simulate an actual engagement. It's a real-world scenario versus trying to find all the holes.
Through the entire process of our project, we use Scrum and Agile methodologies to develop our solution, and we were given a epic user story to begin with to set our criteria. And says, as a red team operator, I want an automated method for deploying and securing red team infrastructure in cloud providers, so I can save time, reduce manual errors, and ensure consistency in my configurations. So we took that, we made a criteria off of that, but we also created a few other user stories to get a bigger picture on what our solution could provide for other red team operators, as you can see below. And this was our Scrum/Agile board. We had our product backlog to do in progress and done. We'd make tasks and complete them throughout the year we worked on this. And then all of our user stories were down below that we wrote. The problem statement we came up with was that we believe there's a lack of an automated solution for deploying red team infrastructure across cloud platforms, and it hinders efficiency, introduces security flaws, impedes scalability, and it needs to be deployed and operate in operational environments. So the problems we identified was inconsistency in configurations, a lack of portability and scalability for red team infrastructure, and a potential for gaps in security, just because every time infrastructure would be brought up, it would have to be reconfigured manually every time. The solutions we explored were using infrastructure as code, or IAC. That could be using Puppet, Terraform, Jenkins, tools like that, or cloud deployments, which could be AWS, Azure, Google Cloud, and other automated hardening tools like Ansible. This was our use case scenario diagram. So it starts off with like the first use case with the red team admin and the new red team operator, and then goes into the regular use case. So the first thing that a operator would do would create an AWS account, generate access keys, and store those access keys, where then a new red team operator would request the credentials from the admin and then be able to go into the regular use case, where they would run the bash script we created, set configurations for what infrastructure they want to deploy, run Terraform apply, which those resources would be deployed through AWS, and then the red team operator would be able to use those tools and servers, and then come back around and Terraform destroy when they're done with an engagement.
So our project objectives primarily were to create deliverables for providing a possible solution for cloud deployments, supporting common red team tools and infrastructure like Bastion hosts, team servers, leveraging automation through infrastructure as code, composed of scripts, images, and configurations, deploying in under 15 minutes, and then upon Terraform destroy, leaving no trace, and considering and following security best practices. So phase one of our research began in May of last year. We investigated existing methods for deploying red team infrastructure, which was primarily a manual approach for most teams, identified common components, potential cloud providers, and identified and explored automation tools and services, infrastructure as code, and then research security best practices for a red team deployment. Phase two then started in July. We designed our initial architecture for AWS, the cloud provider we chose. We'll get into that in a little bit about why. By identifying the required Terraform modules and Ansible playbooks that would be required for the deployment, the variables that we would need to input for things that the red team operator may want to choose on the fly, planned our deployment workflow, and then designed a security strategy. And this is our phase 2 design architecture. You can see the persistent infrastructure is in a subnet, and then we have a ephemeral infrastructure. So our initial idea was to put all of the infrastructure that takes a lot of time to deploy behind relays and redirectors, so that if blue team were to detect them or block them, we could rotate out relays and redirectors instead of the actual infrastructure. And those were in separate subnets.
For a phase 3 design implementation, it ran from September to October of last year. This is when we really started developing our code base. We developed many Terraform modules, which were the things that asked AWS to deploy infrastructure. We created Ansible playbooks to install the tools and dependencies onto those pieces of infrastructure. We wrote a bash script to be able to deploy everything easily. Integrated security measures like security rules, firewalls, etc. And we tested small-scale deployments and unit testing. And the picture on the right shows like our main repository where all the Ansible playbooks are in the Ansible playbooks folder. All of our Terraform modules are in the modules folder, so that's like all the pieces of infrastructure. And then in the main repository, we just have a few important pieces of Terraform infrastructure, like the main.tf that deploys infrastructure that cannot be configured. So this is our design implementation diagram. So it's a little bit different than the phase 2 one. We decided that the relays didn't need separate subnets and that they would be rotated out if any of them were found out by a blue team. It also connects via like a internet gateway here, as well as a red team connecting to the Bastion host with internet gateway to be able to see the servers. We still kept up with the persistent versus ephemeral infrastructure. It's just all of these relays would be rotated out instead of them individually.
So phase 4 was our design testing optimization phase, final phase of our actual development from November and December. We refined and optimized the deployment, especially to hit that 15-minute mark. Implemented error handling and logging. It creates very verbose logs so that you can go back after the fact, see everything that happened in case there are any errors. Created documentation. So there you can see our initial white paper, which has been heavily modified now for this conference, but and then also user documentation, user guides, and then testing large-scale deployments, so integration testing. And this is our final infrastructure diagram. We kind of changed our mentality, thinking of it as more ephemeral and persistent, and we changed it to public and private. So everything still up there goes through the Bastion host for the private subnet, and then the Bastion host can connect into the private subnet. And then any of those resources that do need internet access can go through a NAT gateway, and that way the NAT gateway can rotate out the public IP in case it gets blocked that way. And the NAT gateway was much more rapid to swap out.
Let's start with the results section. So for design requirements, we decided to go with AWS as our cloud source provider because of the documentation and the simplicity in setting it up. Also, there was the free tier, which we were able to use in our early development. And we configured and launched resources using Terraform. Terraform also had really great documentation and was able to give us that consistent, repeatable deployment. And for automation of installation of those resource dependencies, we used Ansible. It was very easy to install and fully deploy. It's also open source. And to be able to deploy within 15 minutes, we actually had to upgrade our infrastructure, our AWS infrastructure, from the free tier to more powerful pieces of infrastructure to be able to install quickly. For infrastructure architecture design, we have a few pieces of non-configurable infrastructure that you can't choose whether you want to deploy it or not, such as the Bastion host, which is basically the it's like it acts as a firewall, and you can only access the servers through it if you're able to SSH into it. The C2 servers are also another piece. You could either do Havoc or Sliver, where Havoc is a GUI-based C2 server, while Sliver is a command line version. The HTTP redirector was also not configurable. It's used as a relay for the C2 server, and Red Elk was our security event information management tool, which basically aggregates all of the information inside of your infrastructure to be able to analyze what's happening. The optional pieces of infrastructure were the phishing server, mail server, website cloner, Evil Jinx, which is like a on-path attack tool, and then GoFish, which is a phishing campaign tool. So depending on a red team operator's engagement, they could configure what they wanted to do. For our deployment workflow and process, this kind of goes back to the use case diagram where we have our first time use, which is setting up the local machine. For your local machine, you need to install Terraform onto it. It's pretty lightweight, as well as have the repository. And then set up the AWS credentials so you can create IAM users and have different permissions for different people running your infrastructure. For the regular use case, you just run the bash script, as you can see on the right side. That's what the main GUI looks like. It's pretty simple. You can configure your tools in C2 server, run Terraform apply, run your engagement, and then run Terraform destroy. For our design security strategy, we configured it so that Terraform auto-generates key pairs every time you run Terraform apply, so that it's more secure every single time it runs. There's no chance of a key pair getting out between engagements. And then there's AWS IAM user rules. Basically, you have your admin, and then you have like child accounts underneath it that have different permissions depending on what operator you want deploying specific infrastructure. Then we also implemented minimal Ubuntu, which is a version of Ubuntu with a reduced number of packages and comes pre-hardened, which basically means that it's like pre-secured, making sure there's not any vulnerabilities already in that version of Ubuntu. Alternative would be running your own hardening script against it. And then Red Team SIEM as well, like Red Elk, which aggregates all the logs, and you're able to analyze your infrastructure. And then we also implemented segmented subnets and security group rules for kind of a virtual firewall.
For our AWS configuration, we had like root user accounts and IAM accounts. The root user account was prohibited from regular general use. That's a security best practice. Instead, we created IAM user accounts for each human user as well as for each tool. And then each tool had a separate user account per human user that would be using them. That would enforce non-repudiation so that something one operator triggered through Terraform could be tracked back to that user and not just the tool that did it. EC2 and Terraform key pairs, as Natasha just mentioned, were created by Terraform with each deployment, which regularly rotated them out. So if there was a compromise of a key during one engagement, it wouldn't compromise future engagements. And then infrastructure as code deployments are extremely lightweight. Locally, the cloud did all of our heavy lifting for us. As Natasha mentioned, the only thing you need installed locally is Terraform. Here's an image of the console after one of our deployments. This was after we upgraded our infrastructure. You can see some of the things still can be fairly lightweight with like the T3A micros on a couple. Some of the resources did need more compute power, especially the C2 server if you're running Havoc, because we wanted to make it really lightweight locally. It did have to compile the code in the cloud every time it deployed, so that it was pulling from the main repo instead of trying to store things on the cloud. So it needed a lot of compute power to compile that code and get it running. Sliver is a little bit lighter weight. And then there at the bottom, you can see our NAT gateway that you can rotate out for the public IP. For cloud security and compliance, we implemented AWS config and security hub rules following NIST SP 853 for a security baseline. AWS has automated checks, and one of the baselines you can select is 853. With initial scannings of that, we had a security score of only 28% with a lot of vulnerabilities, 4 critical, 19 high, some others. We were able to harden our deployment with a final security score up to 92%. through heavy modification of our Terraform code in order to patch vulnerabilities so they didn't persist between deployments, enabling some of the AWS native services that fulfill some of those controls like Macie, CloudTrail, securing the AWS account configurations, and then all critical and high remediations, critical and high findings were remediated in our deployed infrastructure through modification of the Terraform code so that we didn't have to continuously patch them with every deployment. And then some medium and low findings did have to be accepted or compensated for due to operational limitations or software limitations requiring certain gaps. This is a cost chart. This is after we upgraded the infrastructure. It's important to note when we first started and through most of the research, we were using free tier with costs less than $5 a month for the entire infrastructure. The only limitation there really was deployment time. So you can make this really as cheap as you need it to be or increase the price to get more performance, more storage if you're exfiltrating a lot of data. But that first month, initially $70, the biggest cost there that resulted in the increase was the domain registration. We did purchase rights for a domain for a year to simulate what you, like a phishing attack, you might forward a target to an alternate site, and then around $53 a month for regular use after that. And then timing, one of our metrics for successful deployment was the timing less than 15 minutes. With an increased infrastructure, this is using Havoc, which is the longer to deploy. It's 12 to 13 minute runtime for the apply, and then about a 5-minute destroy.
In conclusion, we're able to accomplish all of our acceptance criteria. We're able to deploy with the cloud using AWS. We're able to support common red team infrastructure components using Bastion host, C2 servers, clients, and mail and web servers. We're able to accomplish an automated solution using Terraform and Ansible. We're able to get our timing under 15 minutes for a full deployment. And we implemented security best practices with minimal Ubuntu, AWS security tools, and the NIST SP 800-53 framework baseline. So for some of our future work, we thought about maybe implementing additional software and red team tools to show the flexibility of this infrastructure for other operations. We wanted to explore more automated responses to blue team activity, optimizing deployment times using multi-threading, exploring mobile device deployment using tablets, phones, or Raspberry Pis, and then using containerization for CI/CD pipelines as well as DevSecOps. Thank you for your time and attention. Are there any questions?
When you were implementing the system, was the blue team active too at the same time when you guys were doing the red team stuff? Or not?
Oh, we had no actual blue team or red teams during this. We actually had to sign something with AWS saying we would not use this infrastructure for an actual deployment. So this was just a proof of concept. So we this could be used in an actual blue team or red team engagement, but for the purpose of this project, we weren't able to accomplish that.
AWS has a lot of restrictions on what you can do pen testing wise on their platform, and you can't target their platform. So it was all conceptual.
Yeah.
That's why in the future you mentioned like doing containerization.
Yep.
Mm-hmm.
Any other questions? Thank you.
Thank you.